Alright, problem number 11, an upside down cone. So let's, again, I always like to visualize this. Upside down cone with a height of 7 and a radius of 2 is filled with Kool-Aid. If you pour the Kool-Aid into a cylindrical cup with a radius of 10, we want to know how high will it rise. Well, let's find the volume of the Kool-Aid in the cone, assuming that it is filled to the top. Well, the volume of the cone is going to be the area of the base, which is going to be 4 pi r squared, times the height divided by 3. That's going to be our volume, and we want to know how high will that rise. Well, let's set that equal to the volume of this cylinder, because that will tell us then how high it rises. So we know that that volume then needs to equal the volume formula for this cylinder, which needs to be the area of the base, which again is pi r squared, so 100 pi times the height. So we need to divide by 100 pi on both sides. So we need 4 pi over, 4 pi times 7 over 3 times 100 pi, all in the denominator right there. So what I would do is I would type this as 4 times 7 times pi divided by, open a parenthesis, 3 times 100 times pi, close your parenthesis. I actually wouldn't do that. That's silly because the pi's cancel out. So it's just 4 times 7 divided by 3 times 100. I'm just going to say divided by 300. So let's figure out what that is. You should get 0.093 centimeters. That 3 is repeating, which is a very small number, but that makes sense because the radius is a lot bigger than the radius of the cone. So it's not going to rise very high at all.